Hello, everybody. Welcome to the TA tutorial for Fluent assignment number 2. So this is the project description right here. So first thing you're going to do is you're going to go ahead and open up Workbench, and let's drag in a new Fluent module. I'm going to do a 30 degrees for you guys, and I'll show you how to change that 30 to 60. So I'm going to go ahead and title my block, keep everything organized. All right, so let's go into our geometry. So once we select that geometry, go over to properties. If you don't see that, right click on it. Sure, click properties. Let's change that analysis type from 3D to 2D because we're working in 2 dimensions right now. And now let's open, I prefer Design Modeler. Let's open it up and get started. All right, now that it's started, let's go ahead and make our sketch. So I'm going to select the XY plane and then look down the Z axis. So that way we're viewing the X and the Y plane right here. And let's create our sketch. So to create our plate, first thing I'm going to do, actually before I do that, I'm going to change the units to make it easier. So go up units, centimeter, because in the project description, the length of the plate and thickness are given in centimeters. So it just makes my life a little bit easier. So rectangle by 3 points. Let's do here, here, and then here. All right. Now let's go ahead and dimension that. So it's going to be thickness of 0.1. Zoom in a bit. There we go. And then it's a length of 30. All right. So it looks like, yep. So since I did the rectangle by 3 points, I was able to put this corner right here on the origin. I always recommend putting everything on the origin with whatever your point of interest is. And for this, I recommend having this vertex on the origin. All right, so now that we got our box, our plate here, we're going to create a box around it. And I'm just going to use the rectangle tool. I'm just going to create a box. Dimensions, let's see. So V3, you see it down here in the bottom left. Let's do 500. Distance, L5, half of 500. Ooh, not that, 250. So what I'm doing here is I am creating an enclosure. I'm making sure that there's enough room for the flow to develop before it gets to the plate. So here we have this right here. Zoom in, we can see our plate right here. Zoom out, see our enclosure. Everything's a dark blue. Looks like everything, since we used the rectangle tool, it looks like everything should be aligned. Sometimes when you use lines, you go through and you try to make shapes with lines. Sometimes when you try to connect vertices, it may look like it's connected, but it may not actually connect, because when you zoom in, sometimes, I may have actually gotten it here, but sometimes it doesn't actually connect, and it can cause you issues going through each and every vertex. All right, so I need to zoom into my plate here because I need to make a angle constraint. All right, zoom in. All right. Sometimes the order you click things makes a difference. All right. Our angle is, we're going with 30. Nope, that's not right. Yeah. Okay. So now we're going to go back to our modeling, select our sketch concept, surfaces from sketches, apply, generate, zoom out. Yep, everything looks fine, looks right, looks fine. Zoom in, our plate is there, cut out. And then if we go to the tree outline, we see our part is here, our surface body. All right, I'm going to change this to a fluid. This doesn't really matter too much because it's going to change in the meshing. All right, let's close Design Modeler. Go back to our workbench, and now we're going to open up our meshing. Take a second sometimes. All right, so now we can see our geometry has loaded in. Verify it here in the tree outline. Our surface body is here. And now let's generate our mesh. Let's just see how it looks. Just a standard mesh. And you can see that our plate is no longer there. So to fix that, we're going to need to go down here to details and mesh. And we're going to turn off mesh defeaturing. It's there, but you can see it's really weird now. We can select there. So what I'm actually going to do is I'm going to go back to the geometry, and I'm going to go ahead and create some name sections. So I'm going to title this front plate, top plate, bottom plate. You can use whichever names you want as long as you know what you're talking about in your analysis. And then rear plate. And to select more than one surface at a time, hold Control. And the shortcut is N on the keyboard for the naming sections. All right, now we can see in the project outline over here, we have our named sections and everything is there. All right, so let's go back to our mesh. I'm going to add an inflation on the entire geometry, but then for the boundary scoping, zoom in, select all the faces. All the edges. So should have them all. If I click apply, yep, I got all four. I'm gonna do 5 layers. And now if I generate, you'll see that the plate is there. So now from here, it's just a refinement game. I always add a triangles method whenever I'm doing 2-dimensional. Let me go ahead and do some sizing. So I got 3 edges in there, so I'm missing one. Missing this one down here. So if you click on it, you'll get this little icon right here. Click that plus sign, and you'll see that now adds it to the geometry down there. That's a easier way to make sure you have everything selected. So I'm gonna lower that element size. I'm gonna use 1, to the -3, because if you look at the units, we're back in meters. So even though we changed in design modeler to centimeters, each window is independent of the other one. So this one is by default in metric with meters selected. All right. So I'm gonna turn capture curvature off. There's no curves in here, so there's really no need for it. We'll make the behavior hard. Basically, what the behavior does is if it's soft, then it will treat these vertices, these corners, as kind of irrelevant, and it can cut those corners in your mesh, which you don't want that. And now this is how our mesh is looking. So it's looking a whole lot better than it was a second ago. All right, I'm just gonna add a little bit more sizing to the inlet and the outlet. Just gonna -2. You don't have to do that, but it's a good habit to get into. That is a little bit too fine. That looks good. All right. All right, so we got our name sections, we got our mesh. I think it's looking good. Let's go ahead and close out. Let's go back here, right click on mesh, update. What that does is it brings all the work that we just did in the meshing window, brings it to Workbench. So that way we can use it in subsequent cells, the setup and solution. All right, let's go and do our setup, our solution. Always double precision. All right, so it can take a second to load in. It's very important when you're getting your solver up. You want to make sure that the model is imported correctly. So you'll see the mesh here. You'll see when you name your sections, if you name it inlet, outlet, symmetry, walls, it will automatically set those boundary conditions for you, which is awesome. Makes your life a little bit easier sometimes. So you can see here in the meshing window here, you have your inlet, outlet, and our mesh looks like it imported correctly. So pressure-based, steady. This looks good. So I'm gonna go expand on the outline view. I'm gonna go select my model. I'm gonna use K epsilon, that's my go-to with enhanced wall treatments and the pressure gradient effects selected. It's my favorite model. So per the assignment here, we need to alter the air, the properties for air, as you can see here. So change density to 1.2 kilograms per meter cubed and the dynamic viscosity to 1.8 times 10 to the -5 Pascal. Yep. All right, so we're going to go expand in the outline view. Materials, expand that out. Fluid, expand that out. Open up air. All right, so you can see density here. It's the right units. Just backspace that out. See. Yep. Make sure you click change/create, or else it will not save your changes. If you just click close, it'll just go back to what it was before. Close that out. And now let's make sure our boundary conditions are properly set. So in the project, you can see that the velocity is going to be 15 meters per second. For this tutorial, I'm going to use 20. But for your project, make sure you use 15. So always click apply before you click close. You just do close. Nothing you do in this window will save. Our outlet, pressure outlet, that's fine. Our wall, we can see that all four of our name sections are here on the wall. All right, so next up is our reference values. We're going to compute from the inlet and have the surface body be our reference zone. This is really important for when you get your forces. All right, so our length is 0.3 meters, 30 centimeters. Make sure that velocity is the 15. For me, it's 20 here, but it's 15 for you. Our viscosity, yep, that came over. Density, that came over fine. So now the area is going to be 0.3 because that's the length times the density, or I'm not density, depth. All right. Next up, let's do our methods. Keep it simple. Change your momentum to first order upwind. You don't need second order for this one. All right, now expand out the monitors and let's change our residuals. All right, so if you want to keep an eye on your forces during the calculations, I will go to report definitions, click on new force report, and then we're doing drag for this one, and then just select all those faces. Drag force, not coefficient, force. And okay, close. Let's initialize again. Oh, I didn't do it the first time. Okay. I believe it has froze. And I did not save. So if it does crash, I'll have lost everything. So make sure you save before moving on to the next window. That's a good habit to get into. All right, looks like it's back up. All right. Looks like it converged with 10 iterations. You can see here in the console. If it does not converge, sometimes you need to up the number of iterations or go back and mess around with your controls, your solutions, your methods. Don't really worry about the controls right here. All right, so we're ready to run our calculations. I'm gonna run 1500 iterations and calculate. Yeah, it froze up again. Make sure you save constantly. All right, here we go. So you can see instead of the scale residuals, since I did that report definitions, I did the force monitor. This popped up. If you want to check your scaled residuals and this at the same time, right click on the tab, click sub windowed view, minimize that. And now you can resize these as you want. Now we just wait for it to converge. All right, so if we look on our console, we see that it converged in 1,162 iterations. Awesome. So let's go down and take a look at our results. First thing, let's go back to the tab view. So you can kind of see it kind of converged around the solution, like, I don't know, 300, 400 iterations in. Let's first take a look at our contours. Looks good. Let's check out velocity. That also looks pretty good. All right. So one of the things for the project is going through and doing the shear stress on the top plate. So that's why you one reason to title them differently when you do your name sections. So I'm going to find my top plate and make sure that we do our curve length and cannot plot. All right. I had a feeling I might do this. So let's give this a try. All right. So one of the reasons I always say put everything on the origin is for whenever you need to add lines or anything in your solver, it's really easy to figure out where to start because you know that point right here, that first part of the top plate, that leading edge is right at the origin. So it's gonna be 0, 0. So now I just need to figure out where these are. So I'm just gonna pull my calculator out real quick. Okay. So the direction vector won't really show it very well. You need to go and do the curve length. Um, all right. Moving on, I'm going to show how to do the post-processing part because you need to find show the pressure and velocity contours, which you can show in the solver, the Fluent solver right here. These two contours right here, but they look better in CFD post. So let's show that. So I'm going to go ahead and open up Workbench again and click on results. Let's load it up. Let's look down the Z-axis, and I'm going to create a contour. Just going to title it so I know what I'm looking at. Location, symmetry 1. Just going to add a whole bunch of contours. So now we can see pressure contour for the 30 degree. And then if you add another one, velocity, change that location back to symmetry, velocity, then we need to check off the pressure to see our velocity contour. So there we go. You gotta zoom in, you gotta see what's going on there. And to get the direction vectors, click on the vector icon, location, symmetry. Just gonna take off that contour. Velocity, apply, and you can see the vectors of the velocity. It's pretty cool. Kind of lost my plate there. It's right there, but yeah, it's hard to tell because the plate is so thin, but it's right there. So, all right, let's see. Let's go back. So we have the pressure contours, velocity contours with the vectors. So that's why you have to do the velocity contour in CFD post because you need those vectors on there. Now we got to tabulate the drag forces and drag coefficients. So let's go back to our solver. So if you go under results, reports, forces, double click on that. Let's just click everything. Make sure you click forces. If you click print, it'll print it out to the console. So now let's expand that up. So now you can see everything it's doing right here. So when you're doing the this part of the project with the forces and the drag coefficients, what you want to do is you want to take the forces that Fluent gives out and don't just ignore the coefficients. You're going to take those forces, go into Excel, and you're going to plug in the forces here in the equation, and then get your coefficients that way. I recommend doing it in Excel so you can get a nice table to put into your report. And there you have it. That's the project right there. One more thing, an easy way to go from 30 to 60 degrees. So if you take your block, right click on that, click duplicate. It'll take a second. We're just going to create an exact copy of everything up to your solution into a new block. So I'm just going to retitle that. There we go, 60 degrees. So now we're going to go back into our geometry. Look down that z-axis again, go back to sketching. Now we're just going to change that angle to be our new angle. And you'll see before you generate, you'll see that shape has changed, but the cutout there is still the same. That's because we haven't generated. So don't be worried if you change that dimension and you see this has not changed yet. And you can see that that point is still on the origin. That's good. Go back and we'll generate again. And now you see it's now at that new angle. All right. So the good thing about that is when you duplicate it, open your mesh, needs to reopen, reload your geometry. When you open it again, it takes a second sometimes. You'll see on there that geometry is updated in our mesh. All we have to do, click the update instead of generate, click update. So that way you ensure that that geometry is coming back in. So you make sure that nothing messes up. When you click on that, it keeps all the same values that you had before. So you don't have to go through and remesh everything. You'll save some time. You can see it's still got that inflation on there. Still got that same element size. So that's a easier way to do it.